Hello everyone, and welcome to our webinar on PKI's role in securing the Internet of Things. I'm Julie Olensky with the Global Sign Marketing team, and I want to thank you all for joining us today. I'm happy to introduce today's presenter, Lanson LaChance. Lanson is the Vice President of Product Planning here at Global Sign. He has been heavily involved in rolling out our existing IoT implementations and making sure our infrastructure supports the unique and complex needs that are arising with new deployments. He is also the lead IoT researcher, focusing on identifying trends and guiding Global Sign's product roadmap to support IoT use cases. Please send any questions you have over to Lanson so we can cover them during the Q&A portion after the presentation. You can submit your questions to Lanson using the questions box in your GoToMeeting control panel. We'll keep track and try to answer them all at the end of the webinar. You can also follow us on Twitter at @GlobalSign, where we'll be sharing follow-up materials after today's presentation. And now, over to Lanson.
Thank you for the introduction, Julie. So today we're going to go over PKI for IoT. Hopefully we can give you some food for thought and maybe some new insight into PKI deployments in an IoT ecosystem. We'll start by looking at PKI's role in IoT. Basically a quick recap of traditional security concepts. Then we'll move on to look at some key factors driving new considerations and deployment models. As Global Sign's already been working with some early IoT deployments, I'll give you a quick rundown of some of those. We'll try to cover some of the general solutions we've implemented. To wrap up, we'll provide some insight into some points to address and lay down some guidance as to where we see PKI's role in future deployments. We're going to try to cover a lot of perspective in a short time here, so in some areas we won't go as deep as we'd like, but please do use the question feature to line up any questions for Q&A. Starting off, what is PKI's role in securing the Internet of Things? I think all the traditional information security concepts still apply, so we'll run through those. But overall, really, PKI will serve to support building and maintaining trust in an IoT ecosystem. Aligning with traditional information security principles, the first role we're looking for PKI to provide is strong authentication. Authentication in the sense of authenticating devices to cloud services, between users and devices, and from thing to thing. These are all areas where PKI is a strong solution. And as Gartner and other experts have pointed out, PKI has been used to authenticate machines and servers for decades. So it has really strong proof points, as well as being an open standard for interoperability. Given the types of devices coming online, like smart grids, elements of other critical national infrastructure, health monitors, etc., privacy is a major concern. Encrypting communications to and from these devices is essential. Applying PKI affords some basic and essential mechanisms ensuring the privacy of communications using encryption. And as Jonathan and Tyson from McAfee also point out here, privacy needs to be considered from the outset when implementing any IoT solutions, rather than a just bolt-on feature after the fact. Well, there's no denying the privacy concerns in an IoT ecosystem. I agree in part with Martin here and think it's tremendously important to consider the integrity of data at the time of consumption. Some of the transformative value we see when IoT futures are prophesized relies on devices being able to make decisions and act on their own without human intervention. In these scenarios, both the value and risk are directly tied to the integrity of the data. Consider the impact of scenarios with heart monitors or insulin pumps relying on spoofed data sources. Or what about energy regulating components that need to trust operational execution sent to them? Thinking of these scenarios definitely highlights the value that data integrity of PKI can provide. So we've been issuing certificates to users, computers, and servers for years and meeting these roles with PKI as just described. But how do the new things in the IoT change the game? When we look at the IoT on a whole, one of the distinguishing features is the diversity of devices. As we've seen a huge diversification of mobile devices, we'll see an even greater trend with IoT devices. Each will be more tailored to a specific use case with different specifications and capabilities. If we compare use cases between traditional PKI and IoT PKI, we'll see a notable divergence. Traditional PKI implementations tend to have common themes, like issuing certificates to users for portal access, or SSL certificates for internal or public-facing servers. but every case in the IoT could be a different nut to crack. Within these scenarios, you'll need to consider both the device's connectivity and resources, as well as how these map to the requirements or features you want from a PKI. Many devices and environments will be constrained, like the RAM, storage, or CPU of the devices could be really limited. So this can prevent you from leveraging traditional PKI features. Instead, you'd be forced to explore a feature subset / alternative to meet your needs. Next, one of the bigger shifts when compared to traditional PKI are the trust models needed to support your ecosystem in the IoT. For example, between what actors or elements in your environment does trust need to be established? Is this an open ecosystem where users and devices might be deciding to join on their own accord and not wholly owned or controlled by you? Or is it a closed ecosystem where you control or have authority over all actors in it? We have an example further in the presentation to cover this in additional detail. But given those considerations, how will you embed, bootstrap, or build trust between these entities in your system? The answers to these questions may drive you to some unique or non-standard PKI deployment scenarios. Now on to one of the most common themes of any IoT discussion, which is the massive size and scope of potential ecosystems. These are absolutely essential considerations as traditional PKI has operated on orders of magnitude lower than these new IoT scenarios. And you're going to need to find a CA infrastructure that can match these needs. In addition to the raw number of devices you'll be working with, how do the use case requirements in your ecosystem impact this CA infrastructure? Also, based on the type and constraints of the devices, where and how will you be provisioning them? And how does that drive the performance and capacity needs of your chosen security solutions? Lifecycle management of keys and certificates now requires a combined analysis of device capabilities, their supporting cloud services, as well as the public key infrastructure. This analysis will drive your requirements for how you will manage and track certificates through the lifecycle. Also, what is the lifespan of the target devices you're working with? Can they be updated after manufacturing or their initial deployment? And then based on these questions, you'll want to consider what the technical interface requirements are for your end devices. For example, are they going to be consuming PKI services through an intermediate system, or are you looking to have the devices obtain certificates directly from CA services? Additionally, as many IoT deployments are external customer facing, are there drivers motivating an alignment of costs and revenue models? And if you're going with managed services, can your provider support flexible pricing models that match your business case? So those are a few of the new questions IoT has brought to the table. Let's look at how some of these considerations are being addressed in a few of GlobalSign's existing implementations. Our first example here is with a provider of cellular signal amplifier devices, SpiderCloud Wireless. SpiderCloud's nodes sit within warehouses or office buildings to build a system that extends mobile coverage. During manufacturing, publicly trusted certificates are embedded into Trusted Platform Modules, or TPMs, which enables a secure boot process, mutual authentication, and encrypted communication with the SpiderCloud appliances. They accomplish this leveraging GlobalSign's MSSL platform and APIs to provision certificates during manufacturing, and also during the system lifecycle to reissue and renew the certificates. The next example we have is with Napera. Back in 2008, they became one of the first companies to use a valid, fully vetted X509 digital certificate for networking gear, which they manage over HTTPS. They chose to use PKI to solve their problems of identifying the device and encrypting the connection. To implement this, each appliance has its own unique, fully qualified domain name. They use our API to import the certs onto each device. It was important to them to include the certificate with each appliance so that the end user organization wouldn't have to obtain a certificate themselves or use a self-signed certificate. They also chose to use publicly trusted certificates so that administrators would be shown trust indicators when accessing the devices with browsers, rather than the self-signed certificates which they had used for beta deployments. The next example is with a national network provider securing network access devices. They embed SSL certificates into these devices, which are located in public locations like McDonald's and Barnes & Noble. The certificate on the device secures the connection between the device and the end users, as well as between the device and the company's back-end systems. This is done using our customizable trusted root setup to push certificates onto each device. To manage the risk associated with the physical security and control of the devices, they arrived at a solution using short-lived certificates and replacing them every 10 days. This is an interesting example as it contrasts some of the other use cases as provisioning and installation is done outside of manufacturing. Those are some examples of early-stage IoT deployments, more of a hybrid between standard PKI deployments and the higher volume, varied device deployments that we expect to see as IoT grows. In those cases, existing PKI capabilities were mainly sufficient, but as the number of devices continues to grow and become more varied, it's likely that PKI as it stands today won't be able to cut it. So let's take a look at some of the considerations that will need to be addressed in order for PKI to take on the scale and diversity that comes along with the IoT. When comparing the PKI needs of IoT to traditional PKI deployments, there are a number of top-level areas where they start to diverge and we'll highlight here. Depending on the capabilities or constraints of the devices in your environment, you may be looking at leveraging certificate validity periods much longer than traditional certificate validities. For example, you might want to use this path if you're not able to update the devices once they've been deployed. Conversely, in some scenarios, you may not wish to use revocation services. For example, if you have a more uncertain and dynamic physical environment, you'd look towards using shorter certificate validities with continuous updates to manage that risk. If you end up going with longer certificate validities, you may need to consider stronger than standard cryptographic algorithms and key sizes to meet the future proofing needs. As we mentioned, devices may be resource constrained with processing and storage, and you look towards more efficient algorithms like ECC for faster key generation and signing, or you may wish to consider shorter root hierarchies for quicker chain validation. Bootstrapping trust in the thing ecosystem is a really tricky problem, and is going to vary greatly depending on your environment. For example, you may choose to bootstrap trust by embedding a root with the devices at time of manufacturing. As the certificates deployed in your environments likely will be to address new use cases and functionality, you may find the need to leverage non-standard or custom EKUs to support advanced access control or permission management. Finally, the method of identifying and naming these devices will likely be non-standard. So there's a high probability that they will need to use subject names not aligned with the standard naming conventions. In addition to the unique cryptographic and certificate feature requirements, we need PKI services that can support both the volume and velocity of usage within an IoT ecosystem. As we mentioned before, PKI needs to scale and support millions of certificates rather than the thousands of existing deployments. Additionally, to achieve these high volume scenarios, it's essential that the PKI services are exposed via effective, simple, and flexible APIs for complete automation. And finally, within your ecosystem, you want to understand what the performance and availability needs are of the relying servers and devices. Before we get into some examples of how this newly evolved PKI can accommodate IoT, I want to take a step back and discuss who's driving these changes. There's two key stakeholders to address who will be dictating the use cases and requirements for securing the things in the IoT. First, we have the cloud players, like platform providers or application developers, who are relying and generating value from the data of the things. And then we have the thing manufacturers. In some scenarios, these may represent the same company. In others, they're separate. Each party might have different priorities when it comes to security. For example, a platform provider might be most concerned about the integrity of the data coming into the device, whereas the manufacturer might want to ensure that the device only downloads approved software updates. We'll next look into two scenarios from the perspective of these players. So first, we'll look at the platform provider use case. Here we'll walk through a theoretical cloud provider model. In this example, the provider has a number of services. They have thing web services for the things to consume and collect data through, consumer web portal, an admin portal, a partner web portal, and data web services. And each one of these services, they have a number of actors engaging with those and consuming them. First, we have the things consuming web services. Then we have consumers using the consumer web portal to access the data or analytics for those things. And they may also be interacting with the things directly. Then we have an administrator working for the cloud provider administrating the services within the portal. And the cloud provider might have a couple types of vendors that are either working through their partner web portal to view and access data, or directly integrating to their data web services via API. And then there might be third-party developers or applications that are integrating and providing additional applications on top of the cloud provider model. And they could be integrating directly with the web data services and likely providing access for the consumer through a third-party channel. For each one of these interactions, you'll need to consider what the trust model that is will be sufficient. In this theoretical scenario, we'll propose some options, but in reality, the exact deployment is going to be completely driven by the specific business needs. But there are two basic modes. One with public trust, basically leveraging the public PKI model, and then they have a private trust, where this is a more closed section of the ecosystem. First, with the things connecting to the web services, you'll often be able to get by with a private trust model. With the consumer accessing the web portal, you'll likely be using standard SSL and therefore try to leverage and bootstrap the public trust. With consumers accessing the things directly, it's definitely a more highly debatable area, but the private trust model is often sufficient here, but you might be looking at a public trust scenario as well. With administrators accessing the portal, there's a potential for a closed section of the ecosystem there, so you might be able to get by with private trust. But again, as we've mentioned before, this is very scenario specific, and it could be a public trust requirement there too. With the vendors accessing the data web services and partner portal, you're likely looking to provide a public trust interface for both of those services, as you don't control or have as much authority over the vendor ecosystem. And similarly, with third-party applications, you'd be looking towards a public trust model to secure their access to data web services and also consumers' access to the third-party application. Whereas this connection right here might be the responsibility of the third-party application provider rather than you as the cloud provider. Now let's look at the other side of the field with the device manufacturers. In this side of the equation, there are a number of places in the device's lifecycle where you'd consider integrating PKI. Where and when in this lifecycle you end up choosing ultimately depends on the capabilities of the devices or things in question. The earliest entry point, and one that we've come across a number of times, is to embed both authentication credentials as well as trust anchors via X509 certificates with the device at time of manufacturing or time of software configuration. The nature and features of the certificates used in this case will be driven by your business needs as well as constraints regarding updating the device during its life cycle in the field. However, there's still a number of other times in the life cycle where you may consider provisioning or enrollment. For example, you may have a more flexible platform that affords enrollment of PKI credentials at the time of deployment in the environment. So instead of provisioning the device with actual certificates during manufacturing, you only provision with configuration details, which allows the device to initiate an enrollment process via the cloud services you've set up once it's deployed. But once the device is in operation in the environment, your approach for how you handle the key certificates and trust across the device's lifecycle is again going to be dictated by the capabilities of the device. You may or may not have the ability to refresh or update certificates or keys on the device. These types of considerations will drive PKI and cryptographic choices like longer validity periods or methods of bootstrapping. And as we alluded to before, there may be also some business drivers here, like if you're selling the device with a service, or rather collecting an upfront fee for both, which may constrain or guide your PKI implementation decision. We've looked at how some use cases are driving new technical considerations for PKI, but what about overall IoT security standards? IoT is definitely in its infancy and at full hype. Many implementations, though, aren't focused on security right now, but rather concentrating on the value of their services and devices. The best practices for security are still developing, but some groups have formed to tackle the task. There's a huge number of groups on the problem, but each with its own slightly different perspective and concerns. For example, we're seeing some interesting work from groups like the IETF, who are looking at applying and modifying existing internet standards and protocols in the IoT, but are also doing some good work on authorization and access control. IEEE has a number of vertical specific standard work groups, and one M2M who are working on cross-industry protocols and standards. Across standard groups, there is a good deal of siloing we see in specific verticals or industries. For example, we have Zigbee with a strong focus in energy, Ant Plus in medical devices, and Thread with Google, ARM, and Samsung focusing on home automation. However, many standards and initiatives are really lacking commercial attraction, so there aren't any clear winners yet, and you're going to be best served to lean towards options that aren't locking you into proprietary solutions. So back to the question at hand. Is PKI the answer to securing IoT? We may be biased, but we think it's probably the best option out there right now. It involves established standards and covers all the basics of authentication, encryption, and data integrity. The key takeaway, though, as we've tried to repeat many times here, is that each deployment is going to have its own needs. So you want to work with an IoT CA provider that's flexible and can accommodate your business-driven environments. Focus on avoiding closed standards and leveraging best-known PKI practices, and use existing technology where possible. So thanks everyone for listening. Before we get into the Q&A, I want to give everyone a heads up that we're also planning some related webinars for early next year. One on managing identities in the IoT, and one on our high-volume CA services to accommodate the scalability concerns we discussed earlier in the presentation. So please stay tuned for when those come out. Thanks again for checking out our PKI and IoT webinar. Feel free to get in touch with us on our Facebook, Twitter page, or LinkedIn page, or visit us at www.globalsign.com.